And so our mapping rule for this function would be that you would take 2 over pi multiplied by x minus 1. And this is because the b value is pi over 2. So when we multiply it and affect the actual x value, we're going to reciprocate it, and so it becomes 2 over pi. And then the negative 2 will be multiplied by y, and you add 3 at the end. And so if you think about the original key coordinates of our sinusoidal function, we know that at x 0, the y is 0. Then it goes to the max at 9 degrees, or pi over 2. And then back at pi would be back at the midline. And then 3 pi over 2 will become negative 1. And then 2 pi is back to the midline at 0. And so if we apply all these, the mapping rule to it, we would get the new points, which is at, so this is 2 over pi x minus 1. And we'll do negative 2y plus 3. If we apply it correctly, we'll get negative 1 and 3, 0 and 1. Here it's pi, so it would be 2 over pi times pi. So that cancels out to being coming just 2. Subtract 1, you end up at 1. And then you have 3, 2, and 5, and then 3 and 3. And so if I plot those points in, I get negative 1. Oops, my negative 1 will be here. Will be at 3. And at 0, it'll be at 1. And then at 2, it's going, at 1, it'll be at 3. At 2, it'll be 5. At 3, it'll be 3. And so we have a graph that looks like this. And this is only one cycle, so we have to continue the pattern. So every 2 is another segment. And so we'll be back at here. So we're just going to continue that. And there's our second cycle. And we're just going to extend that with arrows that go in the right direction. And there we have our sinusoidal function, our new function f of x here. Okay? And if we can check, we can see that the amplitude is 2, as we mentioned over here. We'll see that the b value of the period, it is 4 radians. So if we start here and we end here, this should be 4 radians, which it is. And then our midline is now at 3, and that is true. So there's our midline. And if this was a regular sine function, it would have shifted left 1 unit. So if we look at this graph, it did shift left 1 unit. And then there was a negative, so therefore it is the inverse of what the sine would have looked like, which was normally up and then down. And in this case, if this is our starting point, it went down and then back up. Okay? So it matches all of the characteristics that we saw in the equation. Okay, so now let's do a typical sinusoidal problem, which is a Ferris wheel. So here we have a Ferris wheel with a radius of 20 meters. So the radius of this Ferris wheel is 20 meters. It rotates once every 40 seconds. The passenger gets on here at the bottom, which is 1 meter above the ground. And now I have to write an equation that models the rider's height. So basically, if we think about this graph, we're going to talk about the height as our y-axis, and then our time is going to be our x-axis here. And basically, we see that the rider is going to get on at the 1 meter mark, and then it's going to go slowly up all the way till it reaches the max, and then comes back down, and there's one cycle, and we know that that finishes in 40 seconds. Okay? Where is the max? Well, to figure out this top point here, we know that it's 1 meter to get to the bottom of the Ferris wheel. The radius is 20 meters, so this is 20 meters to get to the center. And then it's going to be another 20 to get to the top. So basically 20 plus 20 plus 1 means that the maximum point is at 41 meters tall. So that's where the max is at. And that's going to be helpful as we calculate all other aspects of the sinusoidal graph. We are starting at the minimum. So if we're going to start at the minimum, the better equation to use, therefore, is going to be a negative cos equation. All right, so a negative cos equation will have a general formula of h at t, because we're talking about height at time, is equal to the a cos of bracket b bracket t minus h plus k. We know, because we're starting right at the minimum, that our h value here is going to be 0, because we're starting right at the minimum, as long as we make this a negative cos to begin with. All right, so that means we have to figure out the other features. So the a value, for example, which is our amplitude, is going to be calculated by using the equation max minus min. Divide that by 2. So our maximum, we said, was 41. Our minimum is 1. Divided by 2, so it's 40 divided by 2, which is 20 meters. Which makes sense considering our radius of our circle is 20 meters. So we'll put that in, negative 20. Our other thing, so we have cos. Now we can calculate our b value. Our b value is related to our period. So we've got 2 pi over our period, which in this case is 40 seconds. So 2 pi over 40, which is really pi over 20. So that is our b value. So I'm going to put that in, cos of pi over 20. And we said that there's no h value, so I can automatically just write t and end the bracket there. And the last feature we have to calculate is our midline, which is our max plus min, divided by 2, which is 41, plus 1 over 2, which is 42, divided by 2. So our k value is 21. I can write that into the equation and put 21. And so there we have it. Our equation of our rider's height above the ground after t seconds is h at t equals negative 20 cos of pi over 20t plus 21. All right, so the second question for this second part of this question is, how high above the ground is a person who has been on the ride for 35 seconds? Leave your answer exact. All right, so let's copy the equation. H at t equals negative 20 cos of pi over 20 t plus 21. And so now we are using the t value of 35 for this question. So h at 35 is equal to negative 20 cos of pi over 20 times 35 plus 21. So remember, we're going to have to do this in exact value. So we're just going to leave this as 35 over 20, 35 pi over 20, which then reduces down to exactly 7 pi over 4, which is a value we should recognize as a special triangle value. And so if we remember, 7 pi over 4, we should draw ourselves a diagram on the Cartesian plane. 7 pi over 4 is almost 8 pi over 4, which would be 2 pi. So really, our terminal arm is going to end in the fourth quadrant here. And it's going to make a triangle and have a related acute angle of pi over 4. And so that side lengths are 1, 1, root 2. So then when we plug that in, we're going to do negative 20 cos, which is pi over 4. And that will be, cos of pi over 4 would just be root 2 over 2. And if we think about the CAST rule, we are in the C quadrant, which means that our value is going to be positive. So that's okay as root 2 over 2. And then I'm going to finish writing plus 21 here. Solving this, I get negative 20 times root 2 over 2, which simplifies. If I cross 20 and 2 out, I get 10 left over. So negative 10 root 2 plus 21. And I'm going to leave it just like that because it said to leave it as exact value. If I go any further in simplifying this expression, I'm going to end up with having to take the root 2, which is not an exact value. So then I can write my therefore statement. The person is -10 root 2 plus 21 meters above the ground. And that's how I'm going to leave my answer, an exact value. All right, have fun.